Alright, so we're going to look at the quotient rule. We've done derivatives of functions like this. These rational functions, or quotients. Remember, a quotient is just the result of things being divided. And we had a couple of options. First of all, we could have reduced the fraction first by splitting it into two separate fractions, 2x over x squared minus 3 over x squared, reduce the x with one of the x's in the bottom, and then that's a 2x to the negative 1 minus 3x to the negative 2, and then we could find the derivative. Negative 2x to the negative 2 plus 6x to the negative 3. So that was one option we had. And to simplify, we do want to have positive exponents. So negative 2 over x squared plus 6 over x cubed.
Didn't we say that was wrong? When you reduced, or no?
This is not wrong. What would be wrong? What would be wrong is to say, hey, the derivative of this is 2, and the derivative of this is 2x, so my derivative is 1 over x. You can't just take the derivative of the top and divide it by the derivative of the bottom. And again, that goes back to limits. When you're taking the limit, if you have the limit of two functions divided by each other, you cannot just take the limit of the top and divide it by the limit of the bottom. Okay? So, and remember, derivatives are just big limits, so we can't do that with derivatives either. But you can do that. You can use the product rule if you change this into 2x minus 3 times x to the negative 2. And then your u prime would be 2, your v prime would be a negative 2x to the negative third, and then when you did your u prime v plus uv prime, okay, you'd have 2x to the negative 2 plus u, which is 2x minus 3, times the v prime, so minus 2x to the negative 3. When you simplify that and distribute, that's a negative 2x to the negative third power. Okay. Then when you distribute, you get 2x to the negative 2 minus 4x, negative 3 plus 1 would be negative 2 power, and then plus 6x to the negative third. And you can see here, this will give you your minus 2x to the negative 2. So here's the minus 2 over x squared plus the 6 over x cubed. Okay, so you would get the same thing in either case. However, we do have a quotient rule. Sometimes we'll be told to use the quotient rule. Sometimes we will simply have to use the quotient rule. Other times it'll just be better. Technically, it would always be possible to rewrite it as a product and do the product rule. Okay? However, that's not always very nice. Okay? Because that just adds another element to it, or you might have to do the chain rule within the chain rule or something like that. So our quotient rule, though, enables us to find the derivative of functions that we either can't reduce or don't want to try to reduce, or don't want to use the product rule with. Okay, so let's look at this quotient rule. We have this quotient of these two functions, u of x and v of x. And the derivative of this quotient is u prime v minus uv prime all over v squared. Okay? U prime v minus uv prime all over v squared. This might be the easier one to remember. It doesn't have all the x's in it. Now, if you learned the product rule the way I was giving it to you, technically we said the order didn't matter on the product rule, how you said it. Here it does because we have subtraction. But the product rule was u prime v plus uv prime. So you'll notice it's similar in the numerator here, it's just subtraction. And then you divide by the original denominator squared. Okay? So going back to the previous example that we were looking at, we had 2x minus 3 over x squared. We already know what the answer should be, but let's look at it one more time. 2x minus 3 over x squared is our y. Okay. U is always the numerator. And v is always your denominator. So, u prime equals 2, v prime is 2x. So if I'm using the quotient rule, what?
2x to the negative 3. Oh, never mind.
That's a good point. If we were using the product rule, we would see this as x to the times x to the negative 2. In the quotient rule, though, you just take whatever is there. All right, that's a really good question there. We don't need to think of this as x to the negative 2 power. All right, because it's just v is whatever is in the denominator already. Okay.
Use the restroom.
So now we have u prime times v, so 2x squared, minus u times v prime. So here's v prime, which is 2x, times the 2x minus 3, and that's all over v squared. Okay? So x squared squared. Alright? Now it's a matter of simplifying. You have 2x squared minus 4x squared plus 6x over, what's x squared squared? X to the 4th. Alright, so now that's a negative 2x squared plus 6x over x to the 4th. If we wanted it to look exactly like the answers we got before, we could split it up into two separate fractions and reduce it. So negative 2x squared over x to the 4th plus 6x over x to the 4th is going to be a negative 2 over x squared plus 6 over x cubed. Okay? So this is a third way we could have done that same problem. Is this the way I would have chosen? Probably not. Okay? But we have three different tools now, three different methods to choose from, and as you do different problems, look for opportunities. Even if you're told use the quotient rule, at least recognize, you know what, I'm using the quotient rule, but this would probably be a better one to do this way. Okay? Keep those things in mind so that when you're not told to do it a certain way, you can. I'll have to look at like IB or something on a quiz, which originally I was planning on having a quiz Friday, and we did a little bit more time practicing than I initially expected, which was fine. So that's going to be Tuesday instead. There's no quiz tomorrow. I updated the post in Skyward, but to say that, but I figured I'd point that out too. I don't wanna try to rush this, cause we've got our chain rule, product rule, and quotient rule, all three of those are gonna be on the quiz. So,
That's next Tuesday.
yeah, Tuesday. Alright, so, but on the quiz, I will ask you to use, at least for a couple of them, I'll say, do this one using the product rule, do this one using the quotient rule.
You're never gonna say like, use this one, but you can't use the quotient rule or something, like, we can always fall back on that if we don't understand the other methods or don't recognize it immediately.
On the quiz, I am gonna tell you, you must use this method for at least once each rule.
So like,
So we can use your method, but if we like get stuck, we can use another method and then kind of just.
You could, and then
Yeah.
kinda reverse
Yeah.
engineer, yeah, that would probably work,
so if we
but,
don't, like, say the first way you did this, we're like kinda shaky on,
uh-huh,
so we use the quotient rule even if you didn't ask for it.
yeah.
You wouldn't say like, you have to not use the quotient rule for this.
No, as long as then you went back and showed doing it the way I asked for. So basically, for the quiz, I'm gonna ask you to do at least one using the product rule, showing all the steps. And I'm gonna ask you to do at least one using the quotient rule.
Okay.
Now, there will be others where you have to find the derivative and there may be no other good way to do it other than the quotient rule or the product rule,
How
okay?
can we know which one we should use?
Well, basically, I mean, here's the thing, I'm kinda trying to help you figure out which method to use as we go. But here's the thing, if you see division, you know you can use the quotient rule. If you're thinking about it and you happen to see a way to reduce, or you happen to see a way to write it as a product, those are alternatives. But anytime you see division, you can use the quotient rule. Anytime you see two things multiplied together, you can use the product rule. Okay?
We have to memorize the formulas.
Yeah, you'll need to know
Is
those.
reducing like a method too, or is that just?
That's just kind of an algebraic thing that we can simplify the function with. Because there, we're not even really finding the derivative yet until we get to here. You know, this is still y, and here's dy dx. Okay, so. Alright, let's take a look at a couple of others here.
Mr. Gibson, sorry, I promise we didn't give much of that one. When we did that problem the first time, like not using the quotient rule, that kept going after we got like -2 over x squared, like do you?
Yeah.
Like we kept going after that and continued to simplify, does that mean you'd have to do that when you're using the quotient rule also?
With the quotient rule, like when you came down here, if you had, I wouldn't complain if you stopped right here. The only reason why I kept going was because, just to prove that it was the same as the other two answers we got,
Okay, so
okay?
in the first one, technically you didn't have to keep going once you got to that part, even though it didn't look the same, but like, that's why you kept going, because it didn't get to a point where you could stop until then.
Well, the reason I kept going is because I had negative exponents. And like I said, I talked to Miss Barheim and she said that is one thing IB, I think some of you weren't here yet. IB doesn't like you to leave negative exponents. So when you're simplifying, we'll make that just a rule for the class too, just always have positive exponents in the end, okay? Alright, so let's work our way through these two. These are two that, frankly, I wouldn't try to use any of the other methods on anyways. So let's just talk our way through this. U is our numerator, so what would U prime be? 1 plus 3x, the derivative would be? 3, okay? And then V is our denominator, x squared plus 1, So what would v prime equal?
2x.
2x. Okay? 2x. So now we have our formula. U prime v minus uv prime all over v squared. So let's plug it in. U prime v minus u times v prime all over v squared. So x squared plus 1 squared. So we should simplify the numerator here. We have a 3x squared plus 3. And then we need to distribute the negative and the 2x into this set of parentheses. So we'd have a minus 2x and a minus 6x squared over that x squared plus 1 squared.
Or you leave it.
I would leave that, yeah. So now we can simplify our numerator a little bit more. That's a negative 6x squared minus 2x plus 3. The only thing I would look for is look to see if you could
Is it 6x squared?
Isn't it 3?
negative, yeah, negative 3x squared, thanks.
Should we FOIL the denominator?
No.
So just leave it.
Yeah, just leave the denominator. The only thing I would look for is there something that we could reduce out of the numerator? But I know this one won't because I only have x squareds. So even if I factored it,
You'd get an
I would
X.
be getting x's, which won't cancel with an x squared plus 1. So I know that's not going to reduce, and we can stop right there. Show me this under here. Okay. So there's our derivative. Not too bad. Not too bad.
What if we do the same problem but different method? Will we get a different answer?
That's the thing, if you used a different method, it might look a little different initially. It will be the same mathematically, and you could do some finagling with it to get it to look the same.
Okay.
But it would be the same. Like if you did this as, 1 plus 3x times x squared plus 1 to the negative 1 power, you would eventually get the same thing. You just have to work with it a little
So
bit.
it doesn't really matter as long as it's mathematically.
Yeah. But honestly, if you're having to do that like to the negative 1 power or something, I think in the end you're doing about the same amount of work. So. Alright, so again, we have y equals root x over 1 minus 2x quantity squared. So there's our u and our v. So take a moment here and try to use the rule yourself, okay? Identify u prime, identify v prime, and plug it into our formula and see what you can do. Alright, what'd you get for u prime?
1/2 x to the negative 1/2.
Okay, good. And how about v prime?
2 times 1 minus 2x times negative 2.
Good, okay. We're using the chain rule. Bring the 2 out. Now it's to the first power. I would go ahead and distribute, which I'm sure you guys probably did. You have a negative 4. You're distributing to the 1 minus 2x, so that's a minus 4 plus 8x for your v prime. You see how now you guys are doing the chain rule without even really thinking about it too hard? Okay. So, but you're visualizing the inner and outer functions and doing that. So, if you're able to do that at this point, that's really good. All right, so dy dx. We've got our u prime v minus uv prime all over v squared. All right, so this isn't really nice, but that's okay. 1/2 x to the negative 1/2 times v 1 minus 2x squared minus u, so make that x to the 1/2 times v prime, so that's a minus 4 plus 8x. And that whole thing is over v squared. So we've got a 1 minus 2x squared that is then squared again. Okay? How many of you guys got that far?
I did differently.
Yeah.
You did
You
differently?
can factor out a.
Yeah, I didn't distribute to the
Oh.
1 minus 2x.
So that you could factor out here?
Yeah.
That works. That works. Because then you would actually, if you did it that way,
Makes your life easier.
that negative 4 would go with this, so it would be a plus 4x to the 1/2 times a 1 minus 2x. So you had that? Okay. And this is plus because we were subtracting, but then we had a 2 times negative 2, we had this negative 4 there, okay? And by the way, one reason you might have chosen to do that is because you anticipated, just like with the product rule, when you have the chain rule within the product rule, you could factor out that binomial. Here, you can factor out the binomial as well, here in your numerator, okay? And actually, that's a good thing to do because when you factor that out, you have a 1 minus 2x, and then you've got times all the leftovers, which we'll get to, but it's going to be over 1 minus 2x to the 4th power. And there you can reduce, okay? And this you will want to do, okay? You'd reduce this with this. Okay, so it'll just be 1 minus 2x cubed in the denominator. Okay. Now we still have the rest of our numerator. We have a plus 4x to the 1/2 here. If we distributed the 1/2 x to the negative 1/2 into the leftover 1 minus 2x, because we took 1 out, but there's still 1 there, we're going to have a 1/2 x to the negative 1/2, so I'll convert that to 1 over 2 root x. And then this times a negative 2x, the 1/2 and the 2 will cancel, so I'm just going to have minus 1.
Root x.
Yeah, x to the negative 1/2 times x is x to the positive 1/2, and now you see you can combine these like terms. So we have 1 over 2 root x plus 3 root x all over a 1 minus 2x to the third.
I think you can simplify it a bit more. If can you move the 2 root x down to the denominator? You can cancel out with the 3 root x on top.
No, because there's addition here.
Okay.
If it were multiplication, but yeah, that's as far as I would go with that. Yes.
I got lost once you put x, that minus x over 1/2.
This.
No. And then
This?
yeah,
Okay. I kind of, you know what? I kind of talked through one step and showed you the last. When I factored out the 1 minus 2x,
yeah, there's one left.
what's left is 1/2 x to negative 1/2 times 1 minus 2x plus 4x to 1/2. Okay, that's just the numerator.
Yeah.
But when I distribute, the half times the 2 gives us the 1.
Oh, I see.
Negative 1/2 times x, you add the exponents. So 1 minus a half would be a half.
Thank you.
Have a good
Bye.
day.
So, alrighty, see you guys. Have a great day.
So no please